Okay, so we are going to do the entry task for Monday and Tuesdays 10, 12, and 10, 13, depending on which class you have. So the first one says you ride your bike 8 kilometers north and 15 kilometers west in 1.5 hours. So remember, underline what you're given and circle what you need. So we're given 8 kilometers north and 15 kilometers west. And the time is 1.5 hours that it takes them to do that. So first we're going to diagram, and we want to make sure that we can see what it is that the path is. And we're going to go 8 north and 15 west. So I'll probably draw it like over here so I can go to the west. So if this is north, I'm going to go 8 kilometers north. And then to the west would be towards the left. I'm going to go 15 kilometers west, not to scale. Okay, so now I have it set up as the path I took. I'm going to get my distance. So remember, distance is total amount covered. So I'm going to basically just add the two together. So I started with 8 kilometers and I added that to the additional 15 kilometers. And I just have to add 15 plus 8 and I get 23 total kilometers. So that is the distance you rode your bike. Okay, now we want the displacement. So remember, again, that's change in position. So this was our start, and this was our finish. So our starting point to finish point, we got to draw that straight line, which gives us the right triangle. So remember, this is a right triangle, and we're finding this line here. So we are going to use the Pythagorean theorem. A squared plus B squared equals C squared. We'll call 8 kilometers A, 15 kilometers B, and the hypotenuse is going to be C that we're looking for. Okay, so now we need to plug in those numbers into the equation. So 8 kilometers, remember I put parentheses and square it. I put the squared on the outside so I can square everything inside. I'm going to add that to 15 kilometers, parentheses around it and squared. And I'm still going to keep my C squared. Haven't dealt with that yet. I'm going to now square them. So remember, you can do it 2 ways on your calculator. If you don't have a squared button, you can multiply to that number by itself, 8 times 8. Or you can go 8 and click the squared button, and you get 64. And remember, we're also squaring the kilometers. So it's going to be 64 kilometers squared, because you square everything inside the parentheses. I'm going to add that to what 15 squared is. So 15 times 15, or 15 squared, equals 225 kilometers squared, equals C squared. So I'm just bringing down the C squared each time until I'm ready to deal with it. Now I have like terms, kilometer squared and kilometer squared, therefore I can add them. So 225 plus 64 is going to give me 289 kilometers squared equals C squared. And now I'm ready to deal with the squareds. So I have C squared and I have 289 kilometers squared. I don't want the squared, I want C by itself. So you do the opposite, which is square root each side of the equation. So what you do to one side, you have to do to the other, which will work out perfect. If I square root C, or C squared, I get C. And if I square root 289, I'm going to take that square root, I get 17. So the answer is 17 kilometers. So I can put that up there in my drawing now that I know what that length is for displacement. Okay, average speed. So remember, speed uses distance. So I am going to use my number up here for my distance. And speed equals distance, we'll lowercase that, distance divided by time. I need an S, a D, and a T, a speed, a distance, and a time. Squeezing it in there with little room. Since I'm looking for speed, it's X meters per second. Oh, that's a lie. It's not meters per second. What actually is it? Got to pay attention to my units. Okay, up here, I did it kilometers in hours. So that was important for me to pay attention to. So my speed unit will be kilometers per hour. My distance that I went, 23 kilometers. And the time took me 1.5 hours. See, that's why it's important to underline all that stuff so I remember what I'm looking for. So I'm going to plug that into this equation here. X kilometers per hour equals my distance on top, 23 kilometers, divide kilograms, thinking mass right now. Kilometers, there we go, divided by 1.5 hours. So we're dividing a kilometer by an hour. Remember, neither cancel. That's why it gives us a kilometer per hour. So now I just plug that into my calculator. So I'm going to go 23 divided by 1.5, and I get 15.333 repeating. So we're going to go equals 15.3. And we're going to circle that and call it kilometers per hour. And if you just put 15 kilometers per hour because you use the right significant figures, then that's perfectly okay. So next one, let's move that up a little bit. So now we need to solve, going a little crazy with my camera. We're going to solve some velocity style problems. So just for the sake of remembering that we have that equation with a circle, I'm going to make the circle over here so we can use it if we need to. So distance on top, velocity and time on bottom. So this one says how much time, so remember that's what we need, so we're circling it. Did it take a bowling ball to roll 18.29 meters? That's the length of a bowling alley, by the way. And it was moving at 5.9 meters per second. So we have a velocity and we have a distance, and we're going to be looking for time. So remember to use the circle. If we're looking for time, we're going to cover up the t, and what's left? We have a d and a v. So it's d over top of v. So the equation we will use will look like this. T equals d divided by v, because that's how it's arranged, d over top of v. So now I'm just going to get my variables written down. So I need a v, a d, and a t. Now some of you might wonder why I always go in this order. Doesn't matter. You can put them in any order. I just do v dt because wherever I put the x is what I'm looking for. So in this case, we're looking for time, so I can just go right down there and put time. Now I have to look at my units. So I have a meters and a meters per second, so most likely I need to find my time in seconds. So it's going to be x seconds. My velocity is 5.9 meters per second, and my distance is 18.29 meters. Okay, so we are going to now solve by plugging it into the equation. So we're going to go using this equation. X seconds equals my distance on top, and that's going to be 18.29 meters, and we're going to divide that by our time. by our velocity, v, 5.9 meters per second. And I'm going to do the math on my calculator. So 18.29 divided by 5.9, I'm going to get 3.1, and that's a time. Okay, so it's going to be seconds. So if I want to go deep into how did we get seconds? Remember, we have a meter over top of a meter per second. So this you multiply by the reciprocal on the bottom, which allows you basically to cancel all of it. But if you do that to the bottom, you also have to do that to top. M is technically over 1, the meter. So we're going to multiply by S over M, seconds over meters. The meters cancel, leaving us with seconds. That's what we want. Now, am I going to ask you to know this on a test? No. But I think it's very important to understand how the units also work out to get to whatever unit we end up with. Okay, so how far does the Saturn V rocket go if it travels at 45,300 kilometers per hour for 3 minutes? So remember, okay, we're Going to do some conversions here because we have some hours and some minutes. The Saturn V, or the Saturn V rocket, was the rocket that took the Apollo missions up to the moon. So it was the most powerful rocket to date when it came to getting basically the capsule and all of the equipment and the people out of Earth's orbit and on their way to the moon. So they did tons of tests on the Saturn V rocket. And it's pretty cool to see all those tests. A lot of them weren't so successful. So how far, that's a distance, does the Saturn V rocket go if it travels? At 45,300 kilometers per hour for 3 minutes. So we are looking this time for our distance. We're given a velocity and a time. Okay, I'm going to write them down still because we need to write down our variables, v, d, t. I'm going to start with them as is and then do the little conversion so we have the correct units to plug into our equation. So the velocity given to us is 45,300 kilometers per hour. And the distance is what we're looking for. Since it's x and we're using kilometers here in our velocity, we're going to do kilometers for our distance. And the time is given to us at 3 minutes. Since these don't match, we're going to do a quick little conversion. So what I do is there's a couple tricks. I know that if I'm going from a big unit to a small unit, like say I'm going from hours to minutes, I multiply. If I'm going from a small unit to a big unit, I divide. So that's my trick. But mathematically, kind of how it works, remember everything's over 1, is if you put a little line out here, whatever one you're trying to get rid of, which is minutes, you put it on the bottom. Whichever one you're trying to go to, whichever unit, you put it on top. And then you write the conversion here. So the conversion is that I know in 1 hour, there's 60 minutes. Okay? So that allows me to cancel my minutes on top and bottom and leaves me with hours. Just basically what I was doing over here without the numbers in it. So I'm basically proving what I just told you. If I'm going from a small unit to a bigger unit of hours, I'm going to divide. So if I multiply everything across the top, I get 3, because 3 times 1, and then basically an hour, because I'm left here with an hour, even though that's not my final answer, because I have to get rid of the 60 down here, use the 60. 60 times 1 is 60. So I have 3 divided by 60, and there's no units on the bottom anymore because we canceled minutes. So now 3 divided by 60 is going to give me how many hours I need. So 3 divided by 60 is 0.05 hours, which makes sense because 3 minutes is not very long when we're talking within an hour. So that's going to be 0.05 minutes. Hours. See, we got rid of minutes. Hours. There we go. So now I have my time, I have my velocity, and I can find my distance, and they all match: hours, kilometers, kilometers per hour. So knowing that, and knowing that I need to use my circle to find my equation, D is what I'm looking for, cover it up. I get V next to T, which means my equation will be distance equals velocity multiplied by time. They're going to be multiplied together. And now I just plug it in. So X kilometers is my D, equals my velocity, 45,300 kilometers per hour. And I'm going to multiply that by my time and make sure I use my time I just found, 0.05 hours. And I need to plug that into my calculator. And if you're multiplying a big number by a decimal, you should notice that this number is going to get quite a bit smaller. So a lot of times people think multiplying times something means makes it bigger, but if it's a decimal, it actually makes it a smaller number. So I'm going to divide that by 0.05, and I get, multiply. I said divide, 45,300 times 0.05 equals, there we go. I hit divide when I meant multiply. I'll put it down here. X kilometers equals 2,265 kilometers distance. So that Saturn V rocket ended up getting 2,265 kilometers into the air, going that speed in 3 minutes. Okay, that's pretty high. That's definitely into space. So just a little quick conversion. We have a kilometers per hour, and we're multiplying that by an hour over 1. Okay, so that's kilometers per hour times an hour over 1. Hours cancel, gives you kilometers over 1, or just kilometers, which is exactly what we needed right there. Okay, and that is the entry task.